All right, good morning, good afternoon, everybody. Thank you so much for joining us for today's presentation by Doug Wood on how to make your CAPAs work harder so you don't have to. We look forward to sharing some knowledge with everybody today. So if you have any questions at all during the demo or presentation, we'd love to hear from you. So be sure to either raise your hand or leave a question in the chat or the Q&A section, and we will get those all addressed towards the end. Also, we will be sharing a copy of today's presentation after the end, so we will share a recording and the presentation as well. Like I said, joining me today is Doug Wood, who will be leading today's discussion. Doug is ASQ's Vice Chair and Principal Officer of DC Wood Consulting. He's a renowned author and recognized quality expert. Doug has a background in industrial engineering, and he's a Six Sigma black belt with several publications. Douglas, thank you again for joining us today. The floor is yours.
Thank you, Teddy. Thank you. So I want to just make sure a point is clear here on my title. I'm a vice chair of webinars and education for the quality management division of ASQ, but that's more than half of ASQ, so that works too. So we're going to talk today about CAPA, or corrective action, preventative action. Most people just abbreviate it to the initials if they're deep into the subject. Let's talk about what the steps are here. Okay, first of all, we need to follow some kind of a defined process. Okay, there's a lot of tools. Okay, people say, well, we do 5 whys and we do fish bones. Those are just tools. Those are not a defined process. These tools help you get there, but they're not what make it successful. Being successful in investigating causes and putting solutions into place means you stay on track. You don't rush to conclusions. And most importantly, avoid thinking, I know. The point is, you remember to tell yourself, I believe I know, but I could be wrong. And the reason for that is that we all focus and we all try to anticipate what's next. That's what humans do. And we're so driven to do that, that we find ourselves, oh, I know what this is, and we jump into it. The problem is you'll only see what you believe is there, okay? And if you don't stop and go, I could be wrong, you're not going to see things about the situation. So you begin with describing the problem. It's next very important to map what the process is, because everybody's going to have a different view of what the process is. So you need to put it down on paper so that everyone can agree. Not a detailed process map, just high level. Then you're going to seek causes. And describing the problem gives you the symptoms. Mapping the process tells you where it's coming from. And now you can find causes that come out of the process and meet your symptoms in your problem description. Once you have possible causes, you're going to collect and analyze data on those causes. Otherwise, you're just going to drown in data. And then take that data and analyze them and seek solutions. Okay, so you're going to find probably more than one solution. You're probably going to find more than one cause, but the solutions need to be sought out and tested. And finally, you need to make sure that the solutions stay in place. Things tend to drift back the way they used to be, you know that. So you need to have some way to ensure that things don't drift away. Next. So we have a poll here. We're gonna set up a poll and ask you, some questions here about your issues. So, what problems are you facing right now? And you can pick all that apply. Since you can pick more than one, you don't have to sweat the details too much. You should be able to just check a couple of boxes here, and we'll kind of see what the audience is interested in. Okay, so here's our results. Okay, the winning answers were human error is the stopping point too often, and circling back to review the effectiveness of each corrective action is also a significant problem. Human error, by the way, yeah, I hear that everywhere I go. It's interesting. People don't often ask the question, somebody, because human error is the problem, and they go, well, you made a mistake. They don't ask, how is it that people are being assigned to tasks that they don't understand well? Now, if you think about that, that goes a layer deeper, doesn't it? That can get you into broader issues. Okay, a close second to that would be some of the other categories. But so the point here is that, yeah, human error. We don't want to stop there. I think it's important to remember that humans make mistakes, but most often because the system drives them into a corner and they make mistakes. If you think about this, you might suspect you have a coworker who gets up in the morning and goes, today I'm really going to screw up. Don't name their names. No, don't think of their names. The thing is, they probably don't. People don't plan to make errors, but they do. They get backed into a corner. The system only gave them a couple of options. Okay, so it's the system's problem. Next. So our first step is to describe the problem. Okay, now this is not a sentence. Okay, we often go through this too quickly. Have you ever seen a problem report come from a production area? It's got a big box on it for describe the problem, and somebody writes in that big box, one word, broken. The thing is, they know more than that. I mean, they know what time of day it was. They know where they were standing. They know where the problem occurred. They know when it happened. They know how long it's been going on. There's a whole bunch of questions. What and where and when and to what extent? Also who, but not who caused it. No, you don't want to go who caused it. You want to know who are the experts in this. That's the who question you want to ask here. Who are we going to bring into this thing? Again, how are people giving tasks that they don't understand? That gets you one level below human error. Next. Now, once you've written down your problem statement, and I'm fond of saying, if it's not written down, it never happened. Now you have to write down the process. You want to start simple. And I like using a technique I call a layered flowchart. You start off with 4 to 8 boxes, big steps across your process. And of course, in order to know you're going to do 4 to 8, you have to have a beginning point and an ending point. And you also have to know what is flowing. Usually what is flowing is indicated by your symptoms. The symptoms tell you the unit that is moving. That's where the unit of complaint is. And so you're going to say, well, what's flowing? What's my beginning point? What's my ending point? You're going to create 4 to 8 boxes. And then some of those boxes are going to be more important than others. And so look at your description of your problem and take the individual boxes from your first layer and drop them down and expand them. So each layer should take you 5 or 10 minutes. This is not a detailed flow chart. This is a flow chart to get you oriented. Next. So as I said earlier, you've got a description, you've got the symptoms, and you know what the flow chart is. Now you're going to seek possible causes. I want to remind you at this point that sometimes while you're doing these kinds of investigations, additional symptoms come to light. When those happen, you must go back and revise your problem statement. That's really important. The problem statement is what ties it all together. It tells you when you're done. So you're going to seek possible causes. Typically, we've got these multiple level causes. I've got, here's my problem, and here, you've probably all done 5 whys, right? You ask, well, why did that happen? And then why did that happen? And why did that happen? And that's fine, except 5 whys, as we apply it in North America, we typically do not have enough branches on it. The truth is that causes branch. They always do. It's not one cause of one effect. It's, well, it could be this cause or that cause. The logic tree tool is a little bit more sophisticated than just 5 whys. Logic trees allow you to branch, and that's a much more powerful approach to dealing with an issue. Again, 5 whys is okay if you've got simple problems, but I'll bet you many of your problems are not simple. Next. So once we found a string of possible causes, now we start to gather data. And the first thing I want to tell you is that you're going to gather the data you already have. You might have piles of data, you might have a database, you might have some automatic collection, or you're going to go out and just measure some things that you hadn't been measuring for a while. And you're going to find that in most cases, that data you've gathered is wrong. Even if you've got a good data collection system, the data you're going to get will tell you something you didn't expect, and you're going to have to go back and collect more data. So data collecting and data analyzing is a cyclical process. You go back and forth on it until you finally see what's going on. As I said earlier, sometimes as you're gathering data, new things will come to light. Someone will go, well, did you know about this? And you go, wait a minute, that's another symptom. And you're going to go back to your problem statement and revise it. It could even give you a whole new process to map out and a different place to collect data. That's kind of the way these things go. Look, if you knew what the answers were, you wouldn't have to do this. Next. So we have another poll question here. We're going to ask you about how do you manage these things? And again, you can pick 1, 2, or 3 of these. You might be doing all of them. People are in all stages for this kind of thing. So where are you? What are you looking at? Okay, well, let's take a look at this. Well, the majority of people are using paper spreadsheets. Spreadsheets are great. They're flexible. You can put things together on them. But the thing to remind yourself about a spreadsheet is it's always the second best tool to use for anything you want to do with it. The second best. It's flexible, and that's a plus and a minus. Because it's so flexible, you can do things wrong. And it can take a lot of time updating it, especially once they get big. I mean, I love spreadsheets. I've used spreadsheets every week since 1982, but they're not ideal. Okay, and it looks like just under 50% use a CAPA software that integrates with your quality management system. That's good. So again, kind of a spread on this. This is good. I think the important thing to remember is the software doesn't actually find the solution. It's the humans that find the solution. And I think the software it should enable your people to find solutions. That's the whole point of it. Okay, next, please. So finally, we've found a whole bunch of different causes, and now we have to find solutions, right? There's probably going to be multiple solutions. Some of them are quick, some of them take longer. Some of them are interim, some of them are long-term. Some of them are not practical. Some of them might be too expensive, or some of them might have to be held off until another change happens. The point is, you need to try a bunch of different solutions and test them out. Remember though, that a solution needs to be acceptable to whoever owns the process. If you have a solution that the process owner does not believe in, you have no solution at all. In that case, you've left the problem, you've left the process manager out of the loop. They need to be brought on board. Don't forget about them as you're doing investigation, in other words. Sometimes a solution must be tested to see if it will work. You can pilot things, you can test things, you can even do a electronic models, computer model to see if something would work. The point is that having multiple solutions gives you a much better chance of having the best solution, the optimal solution for your problems. And remember, you're gonna have multiple causes. One of the challenges of this is you might fix your problem with one solution and then the problem comes back later because another cause triggered it. So maybe you're going to need to have solutions for multiple causes. Okay, next please. Now, once we've made the change, we often want to go, well, we're done now, let's move on to the next thing. I'm in a hurry, got to get on, got to move to the next thing. We got another problem here. And you forget to go back and see if your solution stayed in place. So you need to follow up later. This is best done with a calendar, okay? You put a note in your calendar to go back and check and go back and talk to those people and say, hey, how'd that work out for you? And number one, if it worked, good. If it didn't work and they abandoned it, you need to go, well, why, right? And if they didn't like what you did, maybe you can come up with a better plan to roll out your solutions in the future. There's a lot of benefit that comes from going back and revisiting. The military calls this an after action report. Again, an action in the military is some kind of a battle. But these kinds of after the fact reviews of what did we do and how did that work out for us? It's rumored that Napoleon Bonaparte was the guy that first started doing this. It's a great idea though. Go back and did it work? And do we need another solution? Next. So we have another poll for you. And we're asking you here to kind of say, would you like to see how CAPAs could be managed and automated with your QMS? Over half of you don't have an automated way to handle these things. So we're trying to see here if you're interested in that kind of thing. And again, there's a number of ways to do this. So would it help you? Or are you just here to learn more about doing good CAPAs? Or maybe your manager would like to see a demo. So go ahead and provide the feedback for this. We'll make sure to follow up with you later on. Okay, well, very good. Thank you for answering those questions. So let's talk about what surrounds your investigations. What kind of program management do you have that makes sure that your CAPAs actually work? Okay, well, before you get started, understand that you have to understand what your company's strategies are and the environment. Know what your leadership intends. What do they believe is the an acceptable level of failure, right? Maybe zero failure, but that never happens. First of all, this will help you know which problem to attack first. because you got more than one problem. I'm sure you do. And you need to figure out, well, what are we going to do first? And this comes out of your strategy and your environment. Second thing to remember is that you should use a team. One person assigned to investigate a problem will have an echo chamber in their head. And it goes kind of like this. You probably felt this. You go, well, yeah, I know what I'm doing. And then you say to yourself, certainly, I know, yeah, you're right. And you turn back and you go, yeah, you're an expert. And it's an echo chamber in your head and you don't get anywhere. You have to have at least one other person that you can bounce ideas off of, that you can suggest things. Hopefully a friend who can look you in the eye and say, that's the dumbest thing you've ever said. Or to give you another sense of perspective. This is where a team comes in. The other reason to have a team is that frequently it takes more than one head in order to encompass the knowledge necessary to manage a problem or get into a problem. Our processes are complex. There's a lot of moving parts and things, and we need more than one person to gain the expertise in the room to make intelligent attacks on this thing. You might say, well, that's doubling the cost of the investigation. Yeah, but an investigation that doesn't find the solution is all waste. So you need to use a team. And then after you end, you need to go back and consider how this investigation worked. What worked? What didn't work? And how can we improve the CAPA process? There's a technique that I've seen used in a lot of companies while they're doing that review. They have a piece of paper and a line down the middle and pluses and deltas. On one side of it, they write what went right. On the other side of it, they write what went wrong. And you collect this information and you use it to train future teams. So in summary, you need to have a program management system in place. As we said, happens before the issues and happens after the solutions are in place. You need to follow steps in a process. It is not a tool. It is not just a fishbone, okay? The steps in the process are what's most important. The tools you use may vary a great deal. Remember to say, I think I know, but I could be wrong. This is most important for the subject matter experts in the room, because the more of a subject matter expert you are, the better you believe yourself to be correct. But we can all miss things. If you don't have a written problem description, you have nothing. If you didn't write it down, it never happened. And of course, when you keep track of these things, you need to put away your investigation in a lessons learned file so that you can fish it out later on. Don't forget about a lessons learned file. Blaming human error is a waste of time. Yes, we know humans make mistakes, but we also know, and this is from W. Edwards Deming. He said 95% of all problems are the result of the system and 5% are the result of the people in that system. If you make a mistake, you can't change the system you're embedded in. And systems repeat again and again. So systems drive errors. You need to get away from blaming human error. There's something wrong with the system if you're seeing human errors. You need to map your process out. Identify branching causes. 5 whys is just a beginner tool. It's one tool. You might need to do a tree that branches and has multiple whys coming off of different branches. Another quote from Edward Deming, in God we trust, everyone else bring data. So again, this gets us away from beliefs or opinions. You've probably heard a kind of a rough statement about something that everybody has. It says, everybody has blank, okay? But that's just like opinions, okay? It doesn't help us. Bring data. Data proves things. And finally, be sure to test and follow up on your solutions. So this is how you get sticky and effective CAPAs. Next. So we got a couple of references here. The 8D is a method for problem solving, popularized by Ford Motor Company. The root cause analysis is a 10-step program that Duke Oaks put together, and I teach his material as well as the 8D and CAPAs. I teach several versions of this. But the book at the bottom is possibly one of the best books that you could possibly have. It's got 300 tools in it, all of them written simple, understandable. And the best part about the quality toolbox is the table of contents is a matrix. So you want to do this, you want to do that, follow the matrix, it leads you to the tool. So these are our references. We encourage you to look into them. Next. Okay, so here's my contact information. We're going to do questions and answers now. So it's time to stump the chump. Anybody got a question for me?
Awesome, Doug. Thank you so much for that presentation. That was really great. We do have some questions. We've got a question from the audience here. How do you find or make the time to do these investigations?
Yeah, we're often time constrained. We don't have time to do that, right? There's always enough time to do it over and never enough time to do it right. And the real issue is that you have to convince the leaders that they need to invest the time. Okay. And you do that by getting the cost of your problem. That can be in your description. You can describe, this is costing us $1,000 a day or $10,000 a day. And if you have that in hand at the very beginning, you can go to the leadership and say, you know what? We need to invest time in this thing. So that's probably the best way to do it.
Okay, very good. We have another question. This one's in regard to human error. I know we spoke a lot about that today. Why human error isn't a good idea. Generally speaking, humans are always making mistakes.
Yeah. You hear a lot of this these days. People are always talking about artificial intelligence and how it's going to automate human error out of all of our different processes. But the problem is this: we need adaptability and flexibility in our processes. COVID taught us that. We need to be adjustable to new situations that come up. And the problem is, generally, automation is not flexible. It's expensive to change gears. Humans are adaptable. They are flexible. They will see something and can pivot on a dime. Of course, with that comes the fact they might pivot the wrong way. So what we need to do is we need to look at human error as a sequence of thoughts. Are people seeing what's going on? Are they interpreting what they're seeing? Are they making the right decisions off of their interpretation? And is the physical world that they're acting in again adapted to prevent errors? And all the way through that sequence I just outlined, there are steps you can take to reduce and even eliminate human error.
Thanks for that. Is there a difference between one-off problems and problems that are highly repetitive?
Oh, yeah, okay. So one-off problems are often what you run into in safety investigations, right? Somebody got hurt, it just happened once, and you need to do your investigations quickly. So the National Transportation Safety Board, those people that investigate train wrecks? They use all the steps we just outlined. The thing is, they do them in a different order. They will do step one, describe the problem, but then they will gather all the data they can get their hands on and do the analysis on that data. Then they will map the process. And the reason they do that data gathering and analysis quick is because in a one-off situation, you're not going to get a chance to collect data again. All your data is what you're going to get right now. So you gather it right away, but then you go later on. And so our map the process and identify possible causes comes at the end, not near the beginning. but it's the same 10 steps.
Okay, thanks for that. Um, Alrighty, we have lots of questions. So what are your thoughts on using a PFMEA during the CAPA process?
Hey, what was that again?
A PFMEA. It's
Oh, PFEMA. Yeah, yeah. Process, failure modes, and effects analysis. Okay,
thank you.
so I teach that as well. Failure modes and effects analysis is intended to prevent issues from happening. And it begins with an active imagination, usually doesn't begin with a problem. What you're trying to do with a FEMA or FMEA is you're trying to make sure that the system is robust enough that it doesn't break. So you have to imagine how it can break when it hasn't broken. This is a little different mindset. If you have a problem you have to fix, then what you want is CAPA, because now you can focus on what you know is going on, not what might go on. So that's a little different mindset. If you've got too many CAPAs, though, it is time to do a failure modes and effects analysis.
Okay, great. Can you explain how verification of effectiveness for your implemented corrective actions should be based on the opportunity frequency rather than an arbitrary time period?
Well, yeah, okay. Arbitrary time periods are quite common. People will say, you need to, we need this fix in place and, check it in a month. The problem is the situation might not arise again for 6 months, okay? And you might have to do several checks, not just one, to validate that it's really working. Every kind of problem you're going to run into has a different frequency, a different how often it might happen. And so you definitely need to look at it. Some companies do batch manufacturing. They'll make a batch of something and they run into a problem on it, and then they'll shut down that batch and they'll go on to another thing. And then in 6 months they come back and they start making batch 2 of that original item. Well, you're not going to know whether your fix works until you're into batch 2. Is that 6 months? Is that a year? Maybe it's next week. So yes, you can't have a fixed time period for that. It needs to be adapted to the situation.
Thanks for that. Now, when it comes to breaking down human error, um, is there a good tool or an article that you would recommend to the audience?
Oh gosh, yeah. I can't think of one to mind. I do recall something by a fellow who was a fighter pilot. I can't think of his name, but he called it the OODA loop, OODA. Just Google OODA or OODA loop, and I think you'll find some thoughts on that. And the whole concept is here, it's going through the mental process, the flow, the steps I mentioned, observing and interpreting and deciding and acting. And how does that, what can you do at each of those stages to reduce the chances for error in your system design?
Great. I'm sure you're familiar with the term death by kappa. You have too many, yeah, there's too many open, too many to address.
Yeah.
What do you do if you're in that situation?
Well, number one, you kind of got to get help. The first step, though, is priority. You have a list of your CAPAs, and then you have to choose what's most important. Now, importance can be cost, importance can be risk, importance can be, just frequency, and importance can be what's at top of mind for your leadership. Okay, because if the leaders have this fixation on a particular problem, you might not think that's the worst one, but you've all heard of the golden rule, right? He who has the gold makes the rules. And so you need to make sure that the leadership's wishes are considered. That's part of their strategy. So that's the best thing you can do. If you work on the most severe things first and you work your way down, then you're going to be attacking the biggest risky areas.
Do you have any tips on how to get the leadership on board, or at least on the same page?
Okay. Yeah, two things. Number one, what's this costing us? Okay, because they all strategies done in cost, dollar terms. Okay. Um, but the second thing you need is you need a story. Now, many of us in technical fields, we're not used to telling stories, but you've all had stories told to you when you were a child. That's how you learned what the world was. Somebody told you a story. And so what you need to do then is you've got a problem and you think the dollars and cents are just going to go in one ear and out the other. You need to create a story about the problem. Number one, stories have a protagonist. There's a person involved in the story. And then create your story about the problem. Here's why stories are important. Stories change mental maps. A PowerPoint won't change a mental map. A story will. And so if you can pull together a story and explain it in terms that somebody would recognize, then that creates a different mental map in people's heads.
Yeah, no, that's great. Um, so for some of our attendees who are, have a fairly manual process when it comes to identifying issues, for those that when it actually comes down to human error, is more training the answer?
But the question is really not just more training. You don't want to retrain people with what they've already been through, because what that feels like to the people receiving the training is the beating will continue until morale improves. What you want to make sure is, how did the training not reach them? What was left out of the original training? We're getting down below the surface of training. We're getting into what's the content of the training. Was the training good? Okay, I'm going to demonstrate what I just told you about a story. I'm going to tell you a story. So I was visiting a location not far from where I live that makes all of the ammunition for all the military, all the bullets. Okay, and so they have roads all over this property, and some of the roads are designated for you to drive on, and some of the roads are designated for powder roads. Now, powder is what they put in the shell. That's the explosive part. And so the trucks that bring the powder to the production areas have to drive on these powder roads, and everybody else drives on the regular roads. So I went in there and I did the safety training. They have a video, they have you watch it, and you got to do this and don't do that, blah, 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 blah. Nowhere in that safety training did it mention that there were powder roads. And so what did I do? I drove on one of the powder roads. Well, yeah, they kind of yelled at me. I didn't get in big trouble over it. But what? What was, how did they miss that in their training? It would have just taken a sentence. So the point is, training isn't always what you think it is. Some things that everyone accepts as normal are skipped in the training. But we have a new generation. And these generations we're getting, they have had a different schooling and a different upbringing, and they have not learned the things that the oldsters know. And so you need to make sure to tell them. So that's my story. Hopefully that's a demonstration.
Yeah, no, that was great. That was great. Thanks for that.
Mhm.
We're looking, so we're asking about the logic tree here and how
Mhm.
it's different from the multiple branched 5 whys. Can you just elaborate a little bit more on what those differences are?
Okay. Well, so a logic tree, logic tree works like this. It looks like the 5 whys. You have your problem at the top, right? And then you say, well, why did that happen? And what you're going to do is, one step down, you're going to make sure you have categories for every possible cause that could lead to that. If I was dealing with a calibration issue, okay, well, how can calibration fail? Well, I can have uncalibrated machinery, or I could be using the wrong technique, or my standards I'm comparing against might not be stable, uh, or several. So you've got to branch it. You list every single category where a problem might come from. Then you have to answer, well, which of these is most likely? And you might have two of them that are highly likely and the rest that are just not happening right now. So then the ones that are highly likely, you say why for those, and then you drop down and you again list all of the categories that could lead to that branch. So you see what we're doing is we're spreading this thing out. We're getting wider and wider. You don't go down every single branch. Usually you don't have to go down all the branches, but you're going to go down the most likely ones. And you can see what we're doing here is we're putting probabilities on the branches. And when you do that, now you're using data and logic, and it enables you to identify what are the primary roots of this thing, not just a root. I hope that helped.
Yeah, no, that's great. Um, what would you say is a good method or metric to gauge the health of a CAPA system? Is it frequency of problems? Do you use a survey?
Well, the frequency of problems has more to do with your lack of robustness. Okay, and I mentioned FMEA. Okay, so lots of problems means you're missing FMEA, failure modes and effects analysis. However, you're still running problem solutions. You're finding solutions to your issues. I would argue it's not the length of time it takes you to investigate. It is not the speed that you do. It's not the dollar value of the problems that you're solving. The real tell of a good CAPA system has to do with, are you working on the right things and are your solutions staying? Okay, solutions sticking, and are these the solutions that are most important? And usually that's most important to the leaders.
Great. So I know we're talking a lot about, investigating the CAPAs, after the fact, asking those questions.
Mhm.
Uh, how do you investigate an issue if you're not necessarily the expert in the area where that incident happened?
Okay. Well, you're definitely at a disadvantage, okay, if you're not an expert. Now, non-experts will ask what we would frequently call dumb questions. The thing is, those dumb questions can lead you to the right ones. If you have if they have access to people who are the experts. You see, your expert does not have to be in the team all the time. You can have a group of people who don't always know everything, but they're looking at it when they don't know something. They need to be able to go off and grab an expert and say, what do you think this is here? And take 5 minutes of their time, okay? And bring the expert in just to pop in and say, yeah, this is what I see. And then the team can continue to investigate. So you don't have to have the experts all the time, but you need to have access to the people who know. Okay, that is really important. And they don't have to sit on your team the whole time, but you need to be able to reach them when you need them.
Yep, thanks for that.
Mhm.
So I know you've talked about having, many tools in your tool belt
Mhm.
when it comes to determining, investigation of the CAPA. Do you have a guideline of when to use which tool to, investigate these things?
Yeah, that's kind of a tough one there. The book we mentioned, The Quality Toolbox, okay, is a big aid to finding the right tool. Briefly describe to you in that book what Nancy Teague has done. She's, besides the table of contents, which I described as a matrix, okay, then in each tool she comes into, this is where you use it, This is what the steps are. Here's an example, and here's some considerations. This is like 2 or 3 pages. Okay, it's quick, okay, to go through that. And it's got a great index, and it's got a great table of contents. So that kind of tool can help you figure out, well, I need to, for example, you need to gather data, and you don't have the data. It's something that's not being measured right now. Okay, well, how do I gather that data, right? Well, is it a measured value or is it an observed value? Okay, so there's some different tools to do that. If it's something that people can observe and mark, there's something we call a check sheet or tally sheet. Okay, and the tally sheet is kind of fun because the tally sheet can actually you can get an app on your phone. Okay, and you can count things, and then when you tap a button, it outputs it to a spreadsheet. We used to have a piece of paper and people put little tally marks on it. Well, now we've got a phone and it does the same thing. That's a tool. That's a data collection tool. There are more sophisticated data collection tools, but possibly one of the best ways is remember we talked about spreadsheets? Okay, one of the best ways to evaluate a table of data is you drop it in a spreadsheet and look at it. Where are the holes? Where are the unusual values? When do they happen? And again, that's one of the things spreadsheets are great at. Then you need a more sophisticated package. Once you've figured out where the holes are and what's going on, you want to start looking at things like a histogram. Okay, a histogram is just a count of how often different values occur. We call it a bell curve. Okay, and if you take your data and you plot it on this bell curve framework, you got 2 humps on it, you got 2 processes going on. Now you got to go back and figure out what they are. Another tool that you can use to analyze data is just a time chart, just a run chart. What are the values? How are they changing over time? Okay, that's going to tell you another perspective on that. So those are 2 data visualization tools, which are not highly sophisticated, but can help you get. So you see, the tool you use really depends on the situation you're in.
Awesome. I think you answered several questions there, so thanks for that. Another question we have, just a few more. How do you separate the symptoms from the causes of the problem?
Yeah, well, you got to kind of think like a doctor. You've all gone to the doctor, and the doctor starts off by saying, tell me where it hurts. Tell me what is happening. And essentially, a symptom will be an observed thing. Okay, it will be something that you see. It'll be something that you've measured. A cause, on the other hand, a cause will be what pushes those values. Okay, it's what creates those things. Very often we start with causes that are, the inspector missed it. Okay, that's a cause. That's why the problem got out the door. Okay, that is a escape cause. Ask yourself, well, what triggered the problem? Now you got to go upstream. So one of the things you'll find is that symptoms happen at the point, near the point of the problem's discovery. Upstream is where the causes lie. And they might not even be in production. They might be in the office, okay? You can have causes of production problems that begin in the office area. So causes are uphill and symptoms are downhill. That's probably the best way to describe it.
Okay, thanks for that. Wrapping it up here, last question for you, Doug. When it comes to using a QMS system for monitoring these CAPAs, can you kind of bring it home for us and why it's a useful tool?
Well, it helps to have a structure. Okay, if you had a group of production workers and you gave them a toolkit and you said, okay, go out there build a car. It's not going to work. The reason they're successful is they have a structure. There's a designed process that they go through to put things together. Okay. And the same is true of your process management. We call it a quality management system. It's really a process management system. Okay. You're trying to make sure that the processes are successful. That's quality, isn't it? That your processes are successful. And so it's sort of assumed that when you're managing a process, it's going to be successful. In order to make that happen, you have to consider the broad range, okay? And this goes all the way from your supplier's supplier, all the way through you receiving it. It goes through the steps of your process and how it was designed and how people are using it and how the multiple processes fit together. This is quality management. And then finally, you got to find out what your customers are complaining about. Okay. And all of those are pieces of your process that need to be managed. A quality management system is a framework so that you don't leave anything out. Actually, that's what all frameworks are. Use a framework so you don't leave anything out that's important. So a quality management system lets you keep your hand in on all the important aspects and not miss them accidentally.
Awesome, Doug. Thank you so much. This was very knowledgeable for me personally. So I'm glad you were here today. Um, where can we follow you? Is your LinkedIn the best place to kind of hear about you, or do you have any other socials?
Yeah, my LinkedIn is the primary way that I deal with social media. That's a an ideal source. I try to follow that on a routine basis. Yeah, I don't tweet.
All good, all good. Well, Doug,
Okay.
thank you for your time. Again, everybody, we will share a copy of this presentation, so look for that in the coming days. But we again thank you everybody for your time today, and Doug, thanks again.
Okay. Thank you. And everybody have a great week.
Thank you. Bye, everyone.